Lesson 11.3 is all about geometric sequences. Now before we were talking about arithmetic sequences that add the same each time. That's our common difference. So if we started with 3 and we wanted to add 3, we would say it goes 3, 6, 9, 12, 15, because we're adding the same amount each time. That was our common difference. In a geometric series though, or geometric sequence, we're going to multiply by the same amount. And that same amount is, instead of being called a common difference, it's a common ratio. So again, if we started with 3, but this time we wanted to times by 2 each time, then it would go 3, 6, 12, 24, 48, and continue on, each time multiplying by 2. So, just like before, if we ever wanted to find our common difference, we could take any number, any a sub n, and subtract the one before it. So 9 minus 6 would be 3, so that's why we're adding 3 each time. We could take a number, like let's say 12, and divide it by 6. 12 divided by 6 is 2. That's where our common ratio is coming from. So if we wanted to find the common ratio of this particular geometric sequence and use it to find the missing term, again, I would need to find r and say that it's a sub n over a sub n minus 1. So if I used my a sub n as 12, so that is our 1, 2, 3, 4th term. So we'd say our a sub 4 over a sub 4 minus 1 is 3. So I need my a sub 3, which is our 36 right here. So I would say that it's 12 over 36 is going to be my common ratio. 12 over 36 reduces down to 1/3. So 1/3 is my common ratio r. Now that I know my common ratio, I just need to multiply my last term, this 12, by it. So 12 times 1/3, and that should give me my last number. So that's going to be 4. So we would put that right here. So that's how we would use or find our common ratio first, and then use it to find the next term in our sequence. Before we're going to go about finding a particular term, let's go on to the next one and actually learn how you find an equation for the nth term. So notice in this particular sequence we have 5, 10, 20, 40. If we want to find our r, remember it's a sub n over a sub n minus 1. So let's just use 10 and 5. So that would be like our a sub 2, and our 2 minus 1 is 1. So a sub 2 over a sub 1, 10 over 5, so it's 2. 2 is our common ratio. Now that we know r, notice how if we start with 5 and we multiply it by 1, that gives us our first value. If we start with 5, multiply it by our r, which I should say is 2, that gets us to our second value. Now if we do 5 multiplied by our common ratio twice, that's how we get to our third value of 20. Now if we want to get to 40, that fourth value, we have to multiply by our common difference 3 times. So this is our first value, second, third, and fourth. So it looks like each time, if we want to find our a sub n, if we want to find our actual value, we're taking our first value, which is like the 5, and we're multiplying it by our common ratio, our r, a certain amount of times. Here, we're multiplying it by r 0 times. Here we're multiplying it by r 1 time. Here we're multiplying it by r twice, and here we're multiplying it by r 3 times. And notice how if it's 3 here, 3 is 4 minus 1. If it's 2 here, that's 3 minus 1. 1 is 2 minus 1, and this one we multiplied it by 2 0 times, so that would be 1 minus 1. So each time we want to do this, we have to do our r to the power of n minus 1. So if we wanted to find the nth term, we'd say a sub n equals 5 times 2 to the n minus 1 power. So again, we can check and make sure this works. Let's use 4 to see if it actually works. A sub 4 equals 5 times 2 to the 4 minus 1. Okay, 4 minus 1 is 3, so we'd say a sub n equals 5 times 2 to the third power. 2 to the third power is 8, so we'd say a sub n equals 5 times 8, and 5 times 8 is 40. So I guess I should have been saying this was a sub 4. A sub 4 is 40, which is what we got there. So you're going to want to make sure this one, a sub n equals a sub 1 times r to the n minus 1, is in your reference sheet. If it's not, go ahead and put it in there right now. Now we're going to use that. We just found out that a sub n equals a sub 1 times r to the power of n minus 1. Now we're going to use that to find out the sixth term of a geometric series, or sequence, for which a sub 1 is negative 3 and r is negative 2. Now, we could have done a sub 1 is negative 3, and we need to know the sixth sequence, or the sixth term, so 2, 3, 4, 5, 6, and just multiplied it by negative 2 each time. But let's say it wasn't this sixth term. Say we actually wanted like the 21st term. Well, we don't want to have to count out 21 times and keep multiplying by negative 2 each time. We just want to know a quick, easy way to plug in our values. So we would say then our a sub n equals a sub 1 is negative 3 times our r value is negative 2 to the n minus 1 power. And we know that we're looking for the sixth term, which I'm going to use that in blue, so we would say a sub 6, that's our sixth term, equals negative 3 times negative 2 to the power of 6 minus 1. From here, we know that a sub 6 is negative 3 times negative 2. 6 minus 1 is 5. Negative 2 to the fifth power is actually going to be negative 32. So we'd say a sub 6 is negative 3 times negative 32. Now from here, we would say then negative 3 times negative 32, a sub 6 equals positive 96. So that's how we'd find it, just by plugging in everything into our equation. Nice and quick. Or if you wanted to count it out, you would do 3 times the negative 2 gives us 6, times negative 2 gives us negative 12, times negative 2 gives us 24, times negative 2 gives us negative 48, times negative 2 gives us 96. Again, works nice and easy when this is a low value, but if this was not that, if this was 21, you would have to keep going at all of these spots 21 times. It would take a really long time, so it's probably best just to always make the equation. So now that we know how to make an equation and what it looks like when we do, now we're going to learn about how you can use that equation to find other terms. So if we know that we're given a sub 3, and we're given our r value of 2, but we're looking for the seventh term. Well, we need a sub n equals a sub 1 times r to the n minus 1. All we can really do from here is plug in what we know and see what we can find out. We know in this case our n equals 3 because we're looking for a sub 3. And we know that a sub 3 is going to be 96. So I would say then 96 equals a sub 3. And going from this equation, a sub n, or a sub 3, equals a sub 1, which we don't know yet, times the value of r, which is, 2, to the n minus 1. Well, again, we know that our n is 3 from before, so 3 minus 1. So we can actually probably just get rid of this a sub 3 because we know that it's 96. So we would just say 96 equals a sub 1 times 2 to the power of 3 minus 1. Well, 3 minus 1, that's just going to be 2. So we would say 96 equals a sub 1 times 2 to the power of 2. Okay, now from here we know that 2 to the 2 squared is 4. So we'd say a sub 1 times 4. Now we just need to divide both sides by 4. And we would say that 24 equals a sub 1. So now we found enough where we can make a full equation to use with our 7th term. So we'd say a sub n equals a sub 1, which we know is 24, times r, which we know is 2, to the, get rid of that little piece, n minus 1 power. Now from here, we plug in 7 into our term, so we'd say a sub 7 equals 24 times 2 to the 7 minus 1 power. And we would say then that a sub 7 equals 24 times 2 to the 6th power, because 7 minus 1 is 6. 2 to the 6th power is actually 64, so we'd say a sub 7 equals 24 times 64. And luckily we have calculators to help us deal with that kind of multiplication. We'd say a sub 7 equals then, pardon me just a moment here, 1536. So our 7th term is 1536. Now again, we could have started with 96 and said, okay, that's our 3rd value, 4th, 5th, 6th, 7th, 4, 5, 6, 7, with an r of 2. So 96 times 2 would give us 192. Then times another 2 would give us 384. Then times another 2 would give us 700 and, where am I looking, 68. And then times another 2 would give us 1536, which is exactly what we got here. Notice how it got a lot slower as we kept going, because we're multiplying by 2 each time and it's getting bigger and it's harder to do in our head. Well, imagine how hard it would be if this wasn't 7, if this was 109th term. And we'd have to count out 109 things and keep doing our timesing by 2. We don't want to have to do that. We don't want to have to keep counting when we can just plug it into our equation. So again, that's why it's so important to make the equation first. Our last concept for geometric sequences is finding our geometric means. Just like arithmetic sequences had arithmetic means, which were the terms in between, our geometric sequences have means as well. So if we want to find 3 geometric means between 3.12 and 49.92, we would say that we have 3.12 as one piece, 1, 2, 3 missing pieces, and 49.92. That's going to be our kind of mini sequence that we're looking at. So what we know is that this is our 1st, 2nd, 3rd, 4th, and 5th term. So it looks like we know a sub 1 equals 3.12 and a sub 5 equals 49.92. Okay, from there we don't necessarily know our r, but we can use these 2 pieces to make our equation. We could say a sub n equals a sub 1 times r to the n minus 1. Well, in this case, n is 5, and a sub n, or a sub 5, is 49.92. So I would say 49.92 equals our a sub 1 is 3.12 times r, which we don't know what r is quite yet, but we do know our n value is 5, so to the power of n minus 1. Okay, looks like we're on a little bit of a roll here. We can do 49.92 equals 3.12 times r to the 4, because 5 minus 1 is 4. Now we can divide both sides by that 3.12. Give us a little more space to work here. 49.92 divided by 3.12 actually comes out to 16, nice and evenly. So we have 16 equals r to the 4th power. So here's where you'd have to use your calculator and take the 4th root of both sides. That would reduce it down. Now be careful with what you get here though. This side should come out to r, because anything to the 4th power then take the 4th root would just get us our r value. But when you punch 4th power or 4th root of 16 into your calculator, it'll probably just give you 2. But we know that it's positive or negative 2, because negative 2 to the 4th power would also give you 16. So our r could be two possible things. It could be positive 2 or it could be negative 2. And that's very important to keep in mind. Now, if our r was positive 2, then we would say 3.12 times positive 2 would give us a positive 6.24. That times another positive 2 would give us 12.48, because I should put a positive in front of it, times another positive 2 would give us positive 24.96, and again times by positive 2 ends up right where we're supposed to be. But let's say it wasn't our positive 2, say it was our negative 2 value. That way 3.12 times negative 2 would actually be a negative 6.24. Negative times negative 2 would be again another positive. So it looks like this value is going to be positive no matter what, all the time. Positive times a negative. This one could also be a negative 24.96. Negative times a negative would give us positive again. So it looks like this one will always be positive no matter what, which it should be, because that was the one that was already given, so it shouldn't change. So when finding these geometric means, we want to make sure that we denote that this one and this one can be both positive and negative, not just the positive values, whereas this one can still just be the positive value. But that's how you would find those geometric means. So make sure we're asking questions on geometric sequences, otherwise stay golden.